In this video, we only set up the integrals to find the surface area. The function given can be in terms of x or y, and the axis of rotation can be either x or y. Now, recall that the surface area is 2 pi, the integral of the radius times the arc length. So that is the circumference times the arc length. About the x-axis, the radius is y, and if we were to rotate about the y-axis, then the radius is the distance x. The arc length can be either in terms of dx dy or dy dx. So the arc length is the square root of 1 plus dy over dx squared dx, or the square root of 1 plus dx over dy squared dy. For example, A. Y is given in terms of x, and so it's square root of 2x minus x squared. X go from 0.5 to 1.5, and we rotate the curve about the x-axis to form a surface. The radius is therefore y, because we rotate about the x-axis. Y is a function of x, and so we would find dy dx. The derivative of y with respect to x is 1 over 2, the square root of 2x minus x squared, times 2 minus 2x because of the chain rule. That is 2 minus 2x over 2, the square root of 2x minus x squared. We factor out 2 in the numerator to cancel out the 2, so the numerator is now 1 minus x. And in the arc length formula, we would need to square dy dx. So square 1 minus x in the numerator. And in the denominator, the square root of the square canceled out. Also in the arc length formula, we would need to add 1 to the square of the derivative. And so 1 plus 1 minus x squared over 2x minus x squared. The common denominator is 2x minus x squared. We would multiply 1 over 1 to 2x minus x squared so that we can combine both terms. Expanding 1 minus x squared, we have 1 minus 2x plus x squared. But 2x minus 2x is 0, and minus x squared plus x squared is 0. And so the numerator ends up with 1 only. The denominator is still 2x minus x squared. The surface area is therefore the integral. Notice that we found dy over dx. That means the variable of integration is x. So x goes from 0.5 to 1.5. So 2 pi times the radius is y, times the arc length, but the arc length is the square root of 1 over 2x minus x squared. Always simplifying the argument of the square root before we plug it into the formula. 2 pi is a constant multiple. We can move it to the front of the integral. Y is given in terms of x, the square root of 2x minus x squared. The square root of 1 is 1 over the square root of 2x minus x squared. But, so the square root of 2x minus x squared canceled out. And so we end up with 2 pi, the integral from 0.5 to 1.5 dx. So not only we set up the integral, but we simplified it.